Now our next couple of examples will be just a little bit different than the ones we've just looked at. And the first one we have is 2 times the square root of x plus 3y times the square root of x. And I think you'll agree with me that these are like radical terms, but the difference here is that the coefficients are not like terms. So that poses a bit more of a challenge in terms of simplifying this. Now the best we can actually do then in a case like this is to simply factor out the radical expression, which is the square root of x. Then we'll be left inside then with 2 plus 3y. And that's as far as we can go because the 2 and the 3y are not like terms. Now please note that the parentheses are very important to enclose the 2 plus 3y, because when you multiply then back, you'll get back to the original expression. Now for our next example, we have the cube root of p to the 4th q to the 7th minus the cube root of 64pq. And at first, these don't appear to be like radical terms, but as we saw in a previous example, we need to simplify each radical expression first before we make that determination. So in the first radical, we're going to be looking for factors that are perfect cubes. And the largest perfect cube factor of p to the 4th will be p to the 3rd. So we'll rewrite this as p to the 3rd then times p. And the largest perfect cube factor of q to the 7th, I think you'll agree, will be then q to the 6th. That will be left then times q. There. Now in the next radical, we can see that 64 is a perfect cube. So I'm going to write this just temporarily here as 4 to the 3rd power then p cubed. Maybe not really necessary to do that, but it might be helpful in terms of simplifying it in a moment. Now let's go back to the first radical. We can see that the p to the 3rd and q to the 6th, which are perfect cubes, will come out of the radical as p q to the 2nd power. So we're then left inside with the cube root of pq. And in the next radical, the 4 cubed will come out in front as a 4. Then we're left in with the cube root of pq. So now at this point, these are like radical terms, the same radicands of pq and the same index of 3. But you'll notice again that the coefficients are not like terms. So the best we can do now then is to simply factor out the radical expression, which is a cube root of pq. Then we're left inside then with p q squared then minus 4.